Welcome. I am Brian Donahue. I'm Vice President of Sales and Operations with a company called Finsen Technologies. Today's discussion will be led by the one and only Tristan Williams. He is on our Hollywood Squares right below me. Tristan is beaming in from, I would love to say freezing cold, Devon. Actually, it's colder in Tampa than it is in England right now, but you are
It,
wetter, aren't you?
it's much wetter here, yes. It's not particularly pleasant and probably a lot grayer as well.
Yeah. Well, it's flooding, I hear over there. So you have some rivers that are rising. We are hosting a hockey game outdoors on Sunday, and everyone was worried that it was going to rain or it was going to melt the ice at the Raymond James, and it's going to evidently snow. So I don't think we've ever seen snow on the ground in Tampa in the last 50 years at least. So we'll see if flurries or not. But I think most of us Floridians are, we don't like the snow or the cold. But if it's going to be cold, come on, let's snow, right? Okay, so we'll get started here in a second. Welcome, everybody. I'm going to do a quick introduction, then we'll get right into a PowerPoint. We're going to spend just a couple of minutes talking a little bit about the Cheetos effect and some of the co-modalities. I don't want to steal any of Tristan's thunder. Again, I'm Brian Donahue. I'll be hosting you today. Hollywood Squares to this direction is Jess Hartman. Jess, say hello.
How's everyone doing? I'm Jess Hartman. Thanks for having me on, Corporate Accounts Manager here at Finsen Tech.
And Tristan is our Chief Technical Officer. Tristan has been in the UVC industry, and all of us have been in the medical industry for many decades. But Tristan is our Chief Technical Officer and can answer any question. If you do have questions, I'm going to be monitoring the chat, if I can figure out the Zoom chat. And we do have a couple of props here. If you'll indulge us, this is some of the things that we have in the industry that I bring to presentations. And okay, yeah, that's all right. Camera's good. The lights are on. My glasses aren't glaring too badly, and we'll get started. What I'm going to do is just share my PowerPoint. Tristan, is there anything else you want to say before we get started?
Only just simple fact that we really appreciate everybody turning up today. We recognize everybody's busy, but we're very passionate here at Finsen Tech about infection prevention technologies and the difference they can make on an everyday scale. Every single one of us at some point in our lives has been touched by the damage that infection can cause. And when the technology exists, which can deal with that particular infectious body, for example, I've had relatives that have had MRSA and deep sternal wounds. I've had a sister who caught really bad renal E. coli, and all of these can be negated by utilizing this kind of technology. It's not snake oil. It's well tested. It's well proven, as we'll see as we move through the presentation. But rather than just banging on about the actual technology itself today, what I'm going to do is to give you some examples and some context about the risks of infection prevention and how this technology integrates into that. Brian, Jess, is there anything you want to say before we start?
Yeah, I have a video I want to share. Jess found this on LinkedIn. I don't know if our audience plays around on LinkedIn. There's a lot of really good stuff, a lot of really good studies, and there's also a lot of stuff that is so outlandish. So you got to be careful of the source, just like anything you read. But allow me just to share this video quickly. I'll make sure that the sound is on. There's got to be a button here for sound, right? Here's the picture-in-picture. And sound. I don't know if you can hear the sound. Can't hear the sound, can you?
Medical experts teamed up with Japan's public broadcaster.
Through your microphone, we can hear
it. In this video, they gave 1 of 10 participants some of this black light formula.
He represents
and then they went to a simulated buffet. And then they walked around, and you can imagine what happens after an hour. They turn the lights back on and look at the results.
Before an ultraviolet light comes on, the fluorescent liquid is now visible on a lot of surfaces.
Yeah.
Items the so-called infected person had touched. Tongues, pictures, food tray lids.
I believe within 30 minutes, every person had come in contact with it.
Dishes, glassware, clothing, and phones. After half an hour, every participant had come in contact with the liquid. 3 of them had gotten it on their faces.
On their
A
faces.
visual show of how easily a contaminated substance can travel.
So
Brian,
just to give you
I'll
an
share
idea
the
of,
I've
yeah,
got the slideshow here as well, so I'll share it. You should be able to see that, I
just to
think.
give you an idea what this stuff looks like. On the back of my hand, you'll see nothing here. This is what it looks like under blue light. So I have some of that invisible ink. It's also obviously on my fingertip. And now it's on my mouse and it's on my camera because I touched that as well. So Tristan, you're going to get started.
Yeah, just 1 second, just sorting everything out here. That's better. Okay. Right, so everyone can see the screen, can't they?
Yep.
Excellent. So I'm not wishing to be flippant about this, but this is a really, really good analogy, and it's fantastic to cascade down into EVS, into nursing, everybody within any kind of healthcare environment, because it uses really clear language. It's something that Brian, Jess, and I have been very passionate about, and this has become a real sort of movement for us. But from crunch to contamination, we've all dealt with Cheetos. Yes, we do have Cheetos here in the UK as well, just to be clear. So, and I'm a father of 4 children, and if you have a white sofa and children, that's a really, really bad mix. It doesn't matter what color the sofa is, to be honest, but how many of you as parents or as people that if you have friends that have children and they come in with that dreaded bag, do you see this? Cheeto dust everywhere, on every single thing they've touched, from the sofa to the toilet door, to the television remote, to the Legos, to the toy boxes, to the kitchen, to the cupboards, to everything. And it's a really, really useful analogy because that's exactly how infection moves around a hospital in healthcare. We have slightly different complexities and variables compared to just a simple domestic home and toddlers eating Cheetos, but from cheese dust to microbial traces, it's absolutely true. Just like Cheeto residue stains fingers and surfaces, pathogens, and they're invisible, remember, are deposited on every single thing we touch. High touch, high risk environments as well. Pathogens will cling to doorknobs, they'll cling to bed rails, call buttons, they'll cling to anything and everything that they possibly can. And ultimately, if you can see Cheeto stains, imagine what you don't see. It's the same as looking at an iceberg. The Cheeto stains that you can see are the very, very small bit right at the top that isn't going to harm the Titanic. And what lies beneath is the enormous risk, the bits you don't see that aren't instantly visible. And it's the same with pathogens as well. It's a harmless visual, but it's a really, really good concept. And there is a need and a call for new disinfection paradigms. And UVC is a critical part of that. It truly is. And we'll show you why as we move on. But just to give you some example, I mean, the image that you can see on the screen, you take one Cheeto dusted hand, you take one shared keyboard, and you get lots of people with Cheeto dust on their hands. And it's the same with pathogens, with pyrogens, with microorganisms, viruses, whatever word or terminology or classification you wish to use, it is the same issue. And next time you're in a ward, next time you're in a hospital floor, a hospital, we call them wards here in the UK, but a hospital suite where you have lots of patient rooms laid around a central nursing station, look how many people, just stand there and watch. Take 30 seconds. Watch the people using the shared computer. Watch how many people clean it in between uses. How many people clean that keyboard? How many people disinfect that keyboard? This isn't an isolated incident, and people don't think about a keyboard as being something that could potentially, we're all focused on, we've got a fantastic focus on iatrogenic transmission through surgical instrumentation. Great, absolutely 100% the right thing to do. We focus on room cleanliness, which is great. But do we think about the peripherals that service within a hospital? Elevator buttons, hand sanitizer, pumps. Ironically, the bit that you touch is the bit that is never cleaned. And yes, okay, you rub hand sanitizer on your hands afterwards, but what if you just do a partial press and don't rub that bit? You run the risk of contamination. and it's a big risk. And I'm not speaking purely here from just theoretically. I've been working in healthcare for over 20 years. And these are all things that I've seen. Pens. That pen was on a desk in a very prestigious hospital, I won't say where. And people were sharing it. And that's bandage tape around it to hold it together because it was broken, because they didn't have any replacement pens. But how many patients had that been close to? How many different hands had that been through? And yet it was still on the desk. How contaminated is it making the desk? Where do you draw the line? ID badges. I have a personal hatred of ID badges. In the UK, we had, many years ago now, we had a really impressive disinfection awareness campaign, which was called Bare Below the Elbows. So all of the clinical staff, all of the people in the hospital that moved in clinical circles, nothing below the elbow. So no wedding rings, no watches, no bracelets, no cufflinks, nothing. And always short sleeves or rolled up sleeves. And that's great. And then I stood there and watched all of them because they all have their little ID badges so they can get through the restricted area doors, or they can swipe onto their computer. Again, common shared point, computer, to swipe for access to get into patient notes or whatever you're using the system for. And then they're leaning over the patient. They've washed their hands, done a great job. They've got clean scrubs on. They lean over their patient with their ID badge. And how many people who have ID badges on this call have ever cleaned them? How many people have done it? And if you want to ask that same question to your staff, your team members, whoever within your environment, ask it, because it's a very illuminating question. And this is going patient to patient to patient. Invariably, it goes home. No one thinks about that with ID badges. They go home normally with the holder, the user, the operator, and they go in a car. They go home to where your family live. What have they been in touch with? It's scary. And last but by no means least, the humble phone. A recent study found that your surface of your phone is actually dirtier than your toilet because it's constantly touched. Also, a lot of people surf when they're on the toilet, to be honest, use their iPhones,
Yeah.
Angry Bird syndrome and all that. But
It's funny you
ultimately,
say that, Chris. In the white lab coats, you have your phone and your ID badge and the pen in the white lab coat that at the end
all
of the
in one
shift,
pocket.
you just hang up the lab coat and you just hope they get laundered every day, but I don't think they do.
Yeah, but phones are scary. And with more and more healthcare apps coming online and electronic patient notes, and this also extrapolates directly through to tablets. A lot of patient notes now are fully digital or electronic, and they're going patient to patient to patient everywhere within the hospital. How are those tablets being disinfected? The doctor's washing his hands between the patients, great, but he's touching the patient, touching the screen with gloves on, taking the gloves off, washing his hands, going to the next patient, touching the screen, touching the patient. Think of the Cheetos dust. Always visualize the Cheetos dust. It's a really powerful metaphor. So shared infection risks are no joke, and all of these were from live hospitals. A keyboard that had never been cleaned, ever, never been cleaned. It might have been wiped over on the surface occasionally, but think how bad everything is that is underneath that. A mouse, same. And again, these are things that you touch and move, constant sources of everything, and linking everybody into everything. It's high touch, it's high risk environments. Remember, if you can see the Cheeto stains, imagine the unseen. It's what you don't see. So what can be done? Well, firstly, I want to shout out to all of the EVS teams out there. You guys are doing a fantastic job. Absolutely. What you're already doing is, it's not particularly glamorous. It's really hard work. The effect you have is unseen, so it's similar to Cheetos dust, but you're doing a fantastic job. Manual cleaning is hard work. And if we look how generally the infection rates are in hospitals, you're doing a really, really good job. Take what you're doing, and we just need to turn it up to 11, to quote Spinal Tap. We just need to do a plus version of it. What do I mean by that? Vigilance. Vigilance is the plus. We can take vigilance and we can add it into the entire cleaning process. If people have an understanding and using the Cheetos philosophy, it increases the awareness and the vigilance of the teams. And the vigilance comes from understanding the unseen. Vigilance is all about understanding what you don't see. So a layered defense is key. And what I'm going to talk about today is layering your defenses, increasing your vigilance, and doing it through co-modalities. Because there is more than one way to skin a cat. And what you want to do is you want to skin the cat every single way when you're talking about infection prevention and control. So layered defense. What do I mean by layered defense? Well, you need to look at the surfaces. The surfaces everybody touches. All surfaces everybody touches. We need to look at the very air that you breathe. Is it clean? A lot of hospitals now are getting quite elderly. HVAC systems are getting quite elderly. And it's really, really important that we look at the air quality, because not only in terms of how good it is, but also how is it moving? What are the pathways? What's the flow of the air within the hospital? It's no good having clean air come into a room if it's moving to a contaminated patient and then out to another contaminated patient and out into a clean area. What we need localized processing to ensure good air quality and reduction of airborne microorganisms. And objects, everything that you touch, the phone, the pen, the ID card, the keyboard, the mug, the coffee mug. Here's a question. I've been working in IPC for many, many years now. The one place, where I go into, so if I go into a UK hospital, for example, and I go into, we call them theatres, you would call them the OR suite. You walk into the changing room. Oh, no, Tristan, you've got outside shoes on. You need to put a set of theatre shoes on. So they have theatre shoes there. Theatre shoes are generally shared in the UK. And you know what? No one's ever cleaned those theatre shoes, ever. And they are vile, covered in glycine, saline. They're covered in blood. They're covered in biological debris. And you sit there thinking, I've taken a cleaner set of shoes off from outside and put these on, and now I'm going to go into the OR. But not only that, the worst thing is the EVS team, or the domestic services as we call them here in the UK, fantastic efforts to clean the ORs, to clean the hallways, to clean the corridors behind and in front where instruments move in and out behind, to service the periphery of these particular really good systems. Do you know the one? And then you sit down in the coffee room of the OR, which is normally in the middle of all the ORs, isn't it? Or off to one end or something similar to that. And you sit down, look at the people's shoes. People come in, generally these rooms very often are carpeted. And people walk in and they make their coffee and they sit down, they cross their legs. What if that theatre shoe or touches somebody else on the leg and they go back and they touch somebody else on the leg, or they're very close to the patient? It's really frightening. Vigilance, theatre shoes, objects, all those kind of things. And by this co-modality approach, this layering, ensuring that every single link of the chain is broken within the chain of infection, you can really bring your infection rates down hugely. And yeah, I'm not going to lie, it takes investment, it takes commitment, it takes courage, but it's really, really effective. Doing just one point and link of the chain is effective, but it is not as effective as taking out every single link in the chain. All workflow compatible solutions, and you want to make sure any product you bring into your hospital is validated by international science and standards. Why am I talking about that? COVID taught me something. People are not afraid to lie through their teeth. We went from being one of 8 major UVC manufacturers and then COVID came along, pre-COVID. COVID came along and all of a sudden we were one of 50, and some of them just made absolutely outrageous claims along the lines of, we can disinfect a football stadium in 7 minutes. We can do this, we can do that. And some manufacturers are even saying they replaced the manual disinfection cycle, manual cleaning. They don't. The only way UVC, vaporized hydrogen peroxide, and all those products, they are a layer on top of manual cleaning. You need to remove the surface soil to enable all of those modalities or methodologies to get to the surface to do its job. Okay, moving on. But it's all about combined modalities. Thinking about room, thinking about air, thinking about objects, and even thinking about mobile disinfection as well. What do I mean by mobile disinfection? You'll see in a moment. Infection spreads through multiple pathways. Pathogens exploit, they're not fussy. They will exploit air, they will exploit surface, they will exploit object and human vectors as well. Relying on a single modality leaves blind spots. And I'm sure Brian's got a good football analogy for this, but I'll let him come to that in a moment. Manual cleaning misses, and this is an accepted wisdom, the best manual cleaner in the world will miss 50% of the surfaces, because think about a room. How often do you see people manually disinfecting the ceiling, moving all the furniture and disinfecting the walls, disinfecting underneath the windowsills, disinfecting the windows? And there's areas and planes of objects and things that you can't physically do it. You'd be manually cleaning that room for hours, and we don't have the time. Healthcare is such a dynamic environment. Everything is now, move, fast. And then you've got airborne pathogens. The minute that you've essentially manually disinfected a floor, manually disinfected a windowsill, airborne pathogens are still subject to gravity. They still fall downwards. They will still collect on the floor. They will still collect. People very often ask us the question, how long will the room stay clean for after a thaw UVC cycle? So it depends upon is the door open, is the door shut? It depends upon the state of the room beforehand. It depends upon your HVAC systems, all those things. And they can stay suspended for absolute hours. And we have the technology to deal with that very, very quickly. It shocked me during COVID, because we all recognized all of a sudden that COVID-19 was airborne, and that was the methodology or mode of transmission. And I was astonished as to how many governing bodies, for example, like the British Dental Association, they turned around and said, oh yeah, it's fine, in between patients, just open the window for 5 minutes. What's the size of the window? What's the airflow like past the window? Is it next to a busy road? Are you letting diesel particulates in and making the situation worse? So I was really surprised at how poorly equipped the entire healthcare industry is to deal with a very sadly highly effective airborne infectious organism. But it is all about this co-modality. But we need to break the cycle every single point. We need to look at the infectious agents. We're dealing with that. Fantastic. We've got brilliant, you guys have got the CDC in the US. We've got various bodies here in the UK. Look at those infectious agents. And for a healthcare facility, you want to minimize them. We still here in the UK, certain hospitals will always do MRSA swabbing. They will do, C. diff swabbing, anything that they need to do to control what's that inlet, that income, that influx into the hospital. But we need to deal with that in high traffic areas. Do you know the one place in the hospital I've never seen UV disinfection or air disinfection, so UV room and surface disinfection, i.e. the thaw, or air disinfection, air handling via the air system, which you'll see shortly. Never seen it in ER. In the UK, we call them accident emergency A&E. Never seen anything in A&E. And sadly, I've spent quite a lot of time in A&Es for various personal reasons and family reasons. And they are the most disgusting places on earth. And if you want to put people together that have infectious diseases or are drug addicts or are homeless or all those things, and put all the infectious people, mix them in with a few vulnerable people, you know exactly what's going to happen. And then you let them into the hospital. You let them in through the ER. They either come in and become an inpatient, or they stay where they are and they just dealt with an ER and discharged, but they're still coming in through the magical flappy doors. There's still an influx. There's still a risk. And yet, really disappointing that no one's looking at the ER. Anyway, so high traffic areas, very high traffic area, and also it's normally open 24 hours a day, 7 days a week. That then becomes a reservoir. And then you've got patient rooms. Again, another reservoir. Patient rooms, you guys are doing a really, really good job. And we found that's our hotspot. That really is our hotspot. And we work with a lot of hospitals here in the UK and the US. After each patient discharged, the room is manually cleaned and then UVC surface disinfected. Really effective for two reasons. One, you've had a patient in there, you've had visitor traffic in there, you have to deal with all of that. Secondly, toilets, because most of these rooms are en suite. And when they're en suite, you run the risk of aerosolizing some really nasty bugs, for example, C. diff. And by UV treating that area, you're able to lower the bioburden, deal with the aerosolization, and minimize the risk of transmission. So that's one of the portals of exit. Operating rooms, really important to disinfect those. However, I would also always argue, actually, those are one of the cleanest air or cleaner areas within a hospital or healthcare environment. I'm ignoring the OR coffee suite. I'm ignoring theatre clogs for the moment. I'm just talking about the room. Modes of transmission, contacts, droplets, airborne, really links into surface, air, object. Ambulances. I am still shocked to this very day that people are not disinfecting ambulances with UV. We designed Thor to be the same size as a wheelchair so that it could go onto the wheelchair ramps here in the UK and disinfect an ambulance, and we could do it in under 5 minutes. And yet, still, no one's doing it. And yet it takes 7 to 8 hours to properly manually deep clean a UK-based ambulance after an infectious patient, because they're just manual. They're not actually using any kind of technology to integrate into that process. But patient transport, everything like that, really, really important, because again, you've got vulnerable people coming home, chemotherapy patients, et cetera, and going into it.
Hey, Tristan, if I can throw
Go ahead.
out,
Yes.
we were in a couple of hospitals just last week, and the amount of wheelchair transfers that I was seeing from the valet parking up to the floors. And I asked a couple of folks, how often do you clean your wheelchairs? And they said, well, about every 6 months we bring a firm in and they sort of disassemble them, then clean them and put them all back together again. And then we went to stretchers. When you go from a gurney to another, you're transporting people. How often do you disinfect those mattresses and the side rails and that sort of thing? Beds, I think, patient room, to your point, they're getting all over that. But some of these other areas that go between the hospitals, even the food carts, so there's a lot of transporting inside of a healthcare institute, and that's just healthcare we're talking about. Most of the people in the audience today are healthcare. We still see a ton of exposure and cross contamination outside of healthcare in other markets, like obviously schools and cruise ships and prisons and sheriff's departments and back of cop cars. So sorry to interrupt. Go ahead, Tris.
No, that's absolutely fine. But that's a really good point on the wheelchairs, Brian, and I'm sorry to hear that. But if you think especially that the majority of wheelchair users will very well have open bed sores and things like that, or pressure sores in the area
Incontinent.
that's touching that, yeah? Incontinent, so big risk of C. diff, all those kind of things. That's quite scary. That's quite scary. Intensive care units, they tend to be very well looked after. There's a high focus because of people suffering with comorbidity and very complex issues. But still amazed at how many ICUs are not UV disinfected. And susceptible hosts. And this is why healthcare really comes in. We talked about prisons. Prisons are a real issue. I'm not going to talk about that today. We talked about schools. But healthcare, hospitals are the one place where you've gathered all of the susceptible hosts, all of the people with complex issues, lower immune systems, all those issues, and you've put them all in one place. You've gathered them all together, moved them all in. That's the risk. That's why you need to have this level of protection.
Like radiation oncology waiting rooms, absolutely.
Even canteens. People always underestimate hospital canteens or cafeterias or restaurants, whatever you want to call them. They have some of the biggest through cross traffic in a hospital.
Tristan, there's a local hospital here. I'm not going to name it, but it's a level 1 trauma center, and they have a Starbucks in the lobby. And the Starbucks has a door that closes, and the air doesn't move in there, and it's packed. I was there one day, and I counted 25 people in this tiny box of a room. There was no air, and I was like, this is constant. You can't really put UVC in there because there's so many people. But when they close at night, they really should do something about it, because just the sheer amount of staff and visitors that were in that room, it was kind of gross.
Well, I have to admit, I'm always surprised in the US, given the awareness and the accountability for infection and prevention and control, is how many people I see walking outside of a hospital in full scrubs. how many people I see getting in their cars in full scrubs.
Careful, careful. Know your audience. Guilty as charged. And I can tell you what, when you go through the Atlanta airport and you see a young gentleman in scrubs, that person's probably some sort of device rep too. So to your point, I witnessed that myself when I travel.
Yeah, yeah. So there's that to be aware of. So what are the solutions? We've just outlined the problem. We've got huge risk of transmission. We've got the Cheetos effect. You've got a building full of susceptible hosts. You've got a building full of people coming in with infectious organisms. How do you mitigate this? How do you do that? You're already doing manual cleaning and your EVS teams are doing it really, really well. But how do you mitigate this? How do you deal with it? Well, UVC is a proven concept. And for those of you that haven't worked with UVC before, what you see on the screen there is our flagship product, the Thor UVC. But this is constant wave UV. And I want to be really clear on that because I've been to a few hospitals recently that used a different type of system that was very noisy. It made this noise. It clapped because it was flashing quite a lot and people were very uncomfortable with it, especially in the waiting rooms and things like that if it was being used down there. So this is a silent system. This emits light at a pure wavelength of 253.7 nanometers. At that wavelength, the photons within the light beam have just the right amount of energy to go into any microorganism, punch through the cellular wall, and basically disassemble either the DNA or RNA string, depending which type of organism it is. Really effective. This technology has been around for 100 years. This is not snake oil. I'm not telling you, oh, this has got silver ions in it and it will prevent any kind of infection. I'm telling you, this is technology that's been around for 100 years. Our namesake, Niels Ryberg Finsen, he won the Nobel Prize for his work with this level of technology. So it's been around, it's tried, it's tested, it's proven. There is huge amounts of studies. I'm not going to labor the point. What I will say is this is, if it's got a DNA or an RNA string, this system will kill it. And yeah, that does include if you've got plants in a room, but you shouldn't have plants in a healthcare room at all, or vegetation. Highly, highly effective, highly accurate, very powerful. It is the world's most powerful UVC system. There are more guidance. You can see that this technology now is embedded. We have in the UK, the British standard BS86282022. This is a really gold level standard. Really impressive development of this particular standard because UVC was in the wilderness for years. There was no standards, there was no governance, there was no benchmarks that consumers like yourselves could place to understand exactly where you're going to go, or what you want to buy, or what metrics or performance you needed from that particular product. So here in the UK, post-COVID, because there were lots of problems with cheap, nasty stuff coming in that people had lied about, ozone generation, all those kind of things, because cheap bulbs generate ozone, cheap systems generate ozone. Some expensive ones do as well, but I'm not going to labor that point. However, BS86282022, you take any UVC system to an independent accredited laboratory here in the UK, and they will put it in a standard environment. It's non-reflective. It's of a certain cubic volume. All of the samples are prepared in accordance with all the standards. So all of the biological samples are prepared in a way as everything else like EM17272, which is used for vaporized hydrogen peroxide. And it's a certain height, it's a certain distance away from the machine, and you have to achieve certain thresholds. So for example, you have to achieve a certain log kill to sell into veterinary, you have to kill a certain log kill to sell into industrial, and right at the top of the tier, rightly so, sits healthcare. You have to get right up to the top to be able to say, I'm BS8628 validated for healthcare. We also are aligned with, we are compliant, Thor is compliant with that, and we have all the details and data on that if anybody wants to see it. To me, it is the world's best standard for the simple reason that it performance benchmarks any system that goes through it in a common methodology. Because there are so many systems out there where they will say, oh, we tested it in our laboratory. We got this result on this particular organism. And then what you find out at a later date when it eventually comes out the woodwork, that they held it 1 centimeter away from the light. That's absolutely no, that's not reflective of real world conditions. We're aligned with NIST guidance. We have validated decontamination outcomes. We're future ready and evidence backed. And I'm going to move along now. But just to give you a
What's
quick
nice, what's
example,
nice about the BSI is that it's an outside industry standard that industry then has to conform to. In other words, you don't just take tests, your own results, and submit it and say, "Hey, look, we're 90% effective." It's a standard saying you must be 5 log reduction in these organisms using this exact test, and then you have to
exactly.
comply to that. So it's a different way
Yeah,
of
Brian's
looking at
absolutely
it.
right. And just to give you a quick crosswalk on this, if you look at the difference here between BS8628, oh, sorry, my computer's slowing up. The big difference with BS8628 is log reduction targets greater than 5 log across core categories. 5 log, 99, count the nines, 99.999%. And that's across different organisms, yeast, bactericidal, so on and so forth. And it's a really good tool. Now, the NIST system that's being used has no thresholds, just dose verification only. And IUVA, slightly disappointingly so, say log 3, but log 5 preferred. I don't understand what use that is for healthcare. Log 3 is equivalent to Febreze. So yeah, that's a little bit weak. So BSA 628 gives you a really good standard. And any global UVC device should be tested to BSA 628. So you can ask for that even if you're in the US. Can I see your BSA 628 results, please? You can even put it in a tender requirement. It's a British standard, but you can quote it as a performance benchmark that you want in your healthcare facility. So Thor, it's 24 high power bulbs, telescopically goes up and down, so we're able to get under and over objects, because one of the frustrations I always had was that UVC machines tend to be designed and all the calculations done based on empty rooms. In all my 20 odd years in healthcare, there is no such thing as an empty room in healthcare. We use LiDAR mapping, light distance and ranging, using class 1 stereoscopic laser, which is millimeter accurate. That enables us to map the room, map the contents, and calculate the dose for you. Your operators don't have to get a calculator out, or a tape measure, or a ruler, or guess. They can only use the system's calculations, and it's provided for them in a graphical format. Really, really simple. Clinical grade pathogen elimination, and it's compliant with BS 8628. That is
And
room
and it
surface
also,
disinfection. Sorry, go on,
if I
Brian.
can just add something, Tristan, sorry to interrupt. There's a lag here, but one of the things that we're very conscious of, that if there's anything that you can take out of this call, other than the 8628, the BSI standard, is cross contamination. So many of the machines out there actually drag pathogens into a room, and because they create their own shadow, particularly in bathrooms, they're susceptible of having their wheels infected, and dragging through the hallways and into the next room. So one of the things from a design perspective, if you're considering UVC, this UVC is way better than Febreze. Febreze you can spray in the air, but this would get all the air and the surfaces. But with the design of Thor, it's actually disinfecting underneath it and its wheels, so it's minimizing any of that cross contamination. Just look at the design of your UVC system out there, and you'll see what I'm talking about. Many of them, the lights don't even start until above 4 feet in the air, and then the machine itself actually blocks the lights directly underneath it. So huge cross contamination risk.
You can actually see the blue tinged light directly underneath the device. It's the world's only system that has a UVC underslung LED disinfection protocol. And that means that we disinfect directly underneath the device, so it casts no shadow, and we disinfect the wheels. Thor was designed on a Hippocratic basis. So the whole design philosophy was first do no harm. And we felt the biggest risk was cross-contamination, moving room to room to room, where people with the best of intentions could run the risk of making the situation worse through no fault of their own, through cross-contamination. Okay, so that's how we
So
do
back to
rooms and surfaces.
Cheetos analogy. We've now with Thor, we can do the air and surfaces, and Tristan's going to blaze through some of the other modalities, co-modalities that are available out there. Each one of these probably has a competitor, but we're just throwing our example out there. But Tristan, just in spirit of keeping this, under an hour,
Yeah,
let's pick up the pace. And please, are there any questions? Please type them up in chat. Happy to discuss anything.
perfect. Thank you, Brian. I'm very aware of the time. I don't want to keep people late. So now we talk about objects. This is Zeus. So we basically took all the power of Thor and put it into a little cabinet looking in on itself. Our IP here is that every single face of that internal cube has UVC emission on it, every single face. And the lower glass shelf is a special type of glass called quartz glass that is the only glass that allows UVC to penetrate through with no loss. What does that mean? Well, it means it doesn't matter about the shape of the object. You can disinfect it, and in 30 seconds, you can get up to a 6-log kill on some really difficult organisms. What do I mean by that? It means that you can disinfect the front of your phone and the back of your phone. That's what most people think about. Most UVC, every other UVC, because it's our global IP, every other UVC chamber is generally a lamp on the top and a lamp on the bottom. So it means you disinfect the top and you disinfect the underneath. How am I holding it? I'm holding it on the side. So that completely compromises the ability for your phone to be adequately disinfected unless you've got 6-plane exposure. We've had a huge amount of success, a lot of our clients with this particular product in one particular hospital, which is a hospital that specializes in dealing with children with brain injuries. Children with brain injuries have a tendency to chew on toys and books, and they had terrible problems with infections would go around rapidly. By introducing Zeus, it completely reduced that issue. And because it's just UVC light, you can put your keyboard in it. You can put your phone in it. It's dry. It takes 30 seconds. You can put your ID card in it, and it's really, really effective.
Shoes,
Okay,
coffee cup.
so we've done rooms and surfaces, and we've done objects. The final thing we need to talk about is air. And the reason we designed this particular system like this is twofold. The first thing is there is a driving need in healthcare for, everyone thinks that HVAC requirements, if you've got clean air coming in, that's fine. Your HVAC requirements for clean air or disinfected air in your hospital ideally change on a daily basis. How many people are coming in and out of that room? How many people are static in that room? How many doors are open? How many windows? What's the temperature like outside today? So what we did is we came up with these supplemental localized air disinfection systems called AIR, which is the Norse goddess of healing and breathing. This has UVC inside it and a HEPA H14 filtration system. And they're big. And they're big for one single reason. There is no replacement for displacement. Your little Dyson fan sitting on your desk will do nothing in a room that sort of size, as you can see in the picture. Plus, they don't really have a huge amount of filtration, as they use the Coanda effect. This system, big fan, big UVC chamber, big HEPA filter, means we can move up to 2,000 cubic meters of air every single hour through that device. So it means if in a standard sized patient room, you're probably getting upwards of 18, 19 air changes per hour. And if you don't know what air changes per hour you need, go and talk to your estates division or your architect, because there are requirements for this and you have to understand them. Brian, I've talked in cubic meters per hour here. Do you want to touch upon cubic feet?
Yeah, that's 70,000 plus cubic feet. So it would be a room that's 90 by 90 by 9 feet tall. Most rooms aren't that size. So if it's smaller, you're getting more air changes. That's on top of what your HVAC is already doing. So if your requirements, AORN requirements, say in the OR, maybe they're 20 to 25 changes per hour, and you have orthopedics and you have someone that wants to have more air changes, you could have this standalone unit go in there and actually bump up their air changes without having to change the HVAC requirements or get engineering involved. I was in the Cleveland Clinic one day, and they said that that it was too loud And so we went in with a sound engineer, and sure as heck, it was about 83 decibels. And what it was is they turned their air changes up to over 40 an hour, and in so doing, it created a lot of noise. The problem is when they lowered it to 25, the surgeon said it was too hot. So there's a balance between, the surgeons that are in the gowns, the noise, and air exchanges, definitely.
Thanks, Brian. So it's I'm getting an echo somewhere. Sorry, anyway, moving on. Could be you. Okay, so that's air, and it's supplemental as well. So if you need more, you just add more. They're plug and play. They run off 100 volts, NEMA 515s, low power, lower than 40 decibels, night mode, lockable, all those kind of things. And the filter system, if you need to change the filter, I have a bit of a thing, which Brian and Jess, I drive them wild, but it really does help in the long term, which is that to change bulbs and to change filters, no tools required. You just simply open a door at the back, which is like a gym locker, pull the filter out, pull the bulbs out, replace the bulbs. So really, and we also monitor the filter performance as well. We tell you when your filter is going to need to be changed. It's a dynamic filtration system.
And
then
you can
Hermes, sorry,
and you can
go
use
on, Brian.
that air anywhere there's people congregating, or you have an increased risk. So any waiting room makes sense. On radiation oncology makes sense. Obviously, ED, ORs, even PACUs. When you have someone that's just susceptible and you have to change those air, and you can't spend a lot of time thinking about it. The operating room makes a lot of sense, particularly with some of the new plume laws that are coming out. So this is not anything new. There's been, air filtration out there for a long time, but what we've done is we've added HEPA 14, which is the highest standard, to UV, and nothing, and then the airflow with the noise is what you want in the operating room. It's something that's very quiet, that's very effective.
Thank you, Brian. And then finally, we come to one of the smaller items, but nonetheless very, very interesting, which is called the Hermes. And it's quite an innovative design. It's a ball design. And this was designed for vehicular or portable UVC disinfection. So four bulbs, a separate control unit. And the reason it's a ball is you can put it out very, very quickly. You can place it very quickly. It's able to roll. It's able to move. It will roll like a football. You can kick it along the floor if you really wanted to. It still has motion detectors, so it will shut off if someone comes in the room. And I'm really excited for the potential of this, because when we designed this, it was done with the issue of biofilm in mind. A lot of people aren't really talking about biofilm a huge amount, but biofilms in cleaning products like buckets, sinks, toilets, all those kind of things where there's a film which prevents bleach and other additives not being as effective as they should be. And it's really simple to use. It's plug and play, really, really good product. Fantastic for ambulances. Not as good as Thor, but very, very close. We're talking to people about the use of it on aircraft. We've been looking at, been working very closely with several sheriff departments for police vehicles, because imagine the people they pick up. Imagine sometimes what they're carrying on them. So we need solutions for that as well. And Hermes provides that. So co-modality is the best approach you can possibly have. Disinfect the air, disinfect the objects, and disinfect the rooms. And Hermes fills the little gaps in between all of those. So remember, Cheetos, a fantastic analogy or metaphor for the way that infection spreads through any building, any facility, but particularly healthcare, because you've got, as I say, a building full of vulnerable people and a building full of very sick people. Make the invisible visible. Look to break every single link in your infection chain, every single one. Leverage the products, the technologies. There are other unit systems available. There's other manufacturers around, but we're the only ones that take this co-modality approach. We're not just selling one type of UVC. We're selling all the UVC to give you the tools you need to break every single link in that infection chain. Deploy the technology, not just the protocols. You can really work, if you're switched on, to make the UVC deployment of any UVC product more and more efficient and deliver those measurable reductions in HCAIs. Protect staff, protect patients. Design workflows that embed safety and demand data, standards, and proof. As I say, there's other manufacturers out there. But if you take nothing else away from today, if you're interested in UVC, go out there and demand from those people that say, oh, we kill X and we do this and we do it in 6 minutes. Prove it.
And it's
Prove it.
not just the studies on the front end that they did in their own corporate office and submitted to some other, vendor that validated them in their lab. It's also taking dosimeters. There are dosimeters out there. I don't know if everyone has heard the scandal about those other dosimeters, the little cardboard or plastic cards. Major scandal with those things. But there are digital dosimeters, and I encourage everyone to go out and get one. And they come with really cool apps that show exactly what your UVC dosage is. We can point you in the right direction. We have our version. There are other versions out there. But to Tristan's point, not only measure the front end, is it effective, but once it's implemented in your facility, make sure that it's working and that your staff is putting it in the right place and that it's on for the right amount of time. The hardest thing to determine with UVC is dose. So you want to make sure you partner with the right company that can help your people do that.
Thank you, Brian. And remember, all of this means you're going to make people safe. You're going to have people protect the people that are vulnerable, help the people that are sick. But you're also going to have fewer infections, means fewer occupied beds. That means you take a lot of pressure off your teams and you can have lower staff absenteeism and burnout. These are ancillary benefits that people don't talk about. Reduced antibiotic use and AMR risk. And there's a tangible economic impact. A UK NHS trust, for example, reduced their HCAI incidence by 23% within 12 months of implementing constant wave UVC. That's equivalent, if you consider the standard cost of an infection, to £1.2 million of annual savings. So that's really, really significant. Very large hospital. Now, the final thing I'm going to say, and I'm going to hand back to Brian and Jess. I'm aware I've been talking for a very, very long time, and it's 5 minutes till the hour. But I want you to understand our philosophy here at Finsen Tech. We don't want a transactional relationship. We don't want, we don't wear the suits and the trainers, so you buy from us and then we run away. We want to work with everybody on this call as partners. So this partnership line is right in the middle, where all the issues that you face, so pathogen transmission, high touch areas, how do I disinfect this? I'm dealing in a hospital, how do I help the vulnerable? How do I deal with this new complex infection? Meets right at that point, right at that partnership line, all of the things that we do. We don't look after patients, we look after you, and we innovate towards that end. So all the innovation that we do, the 360 6-plane, cabinet disinfection that we do with Zeus and Hyperion, the room disinfection using LiDAR, the Hermes system, which is lightweight and portable and easy to place, that meets with you in partnership. The partnership being, if you talk to us and you have a problem, we have a solution we can help you with. We're dedicated on after-sales support and service. And we really, really work hard. Now I'm going to stop talking. I'll hand back to Brian and Jess for one moment.
If anyone needs any information on our products or anybody else's, like the blue light solution, there's a number of different. I have them all in my office here because I just obsessed with what's going on. Drop me a note. I'll send you a bag of Cheetos, and we're going to see most of you at BayPic. There's a couple other. There's a Central Florida APIC. We're at most of these shows, and if you have any other inquiries, or if you ever want to, compare or contrast what we have with what's existing out there, I can tell you one comment. If you believe in UVC like we do, that's great. You've made that intellectual leap. But however many UVC machines you have, whether it's the air machine in the operating room or the UV robot that is in your patient rooms, you're probably going to need more in the future. Because once you start talking about UVC, I've had this happen to so many people where they come up to me like, gosh, we could use it here, we could use it there. Things that I haven't even thought about. So please comment, send me any questions. If you have any other further need, we're going to send a follow-up email. And I think I sent you guys all the link for that LinkedIn post. Should you need anything else, there's another really cool one out there on YouTube that showed kindergartners And I'll leave you. My last bit is about norovirus. That is a nasty little bug, and it attacks people that are vulnerable. I've got it myself on a cruise. I don't recommend it. We have a nursing home here in Tampa that used they had an outbreak of norovirus and influenza, and they used our products, our air and our Thor, and in 2 weeks, the spread was back to zero. Their infection rate was zero. So we know it works, and it's not just in healthcare. It's everywhere. It's everything you touch, everything you breathe, and how you cross-contaminate. Tristan, thank you for your time. I appreciate it. I know it's Miller time for you. It's what is it, 5 o'clock your time?
It's just turned 5 o'clock. So yeah, there is somewhere in some darkened area of my home a beer with condensation just gently rolling down the side of the glass.
Yeah, well, next time share some pictures. We all want to know what it looks like from Devon.
Fair enough. Okay.
Thanks, folks.
All right.
Thanks for everything.
Chris.
Thanks, everybody.